Welcome to the Titus Timeout Podcast. I'm Jenny Abney-Civi, and today we're going to cover a request I've had a lot lately, which is to demo our team selection software. So I decided to make it this week's podcast. Team 7 was launched a couple months ago when we rolled out our chilled beam product line. Team 7 included the selection program for chilled beams. It's also the beginning of us integrating all of our selection programs into one program. The original Teams program was a DOS program and it only covered terminal units and GRDs. As we added product lines, we added selection programs, including a fan coil program and a displacement ventilation program. But many people don't realize that they already have these programs installed on their computer because you couldn't launch them from what they considered Teams, which was the VAV program. Over the next year, you'll start to see all these programs integrated into one program that we just call Teams. So let's get started. If you don't have a shortcut to Teams, you can launch the program going to the Start bar, clicking Start, All Programs, going down to Titus Teams, and launching Titus Teams Selection. Put it over here on our screen. Okay, from the home screen, you can start a new project, open an existing project, do a quick selection, or close the program. Let's make a quick selection. Quick selection now opens the Select a Product screen. This is new in Teams 7. The pop-up window allows you to select which product line you want to do your selections in. So if you select a program that hasn't been integrated yet, you'll get a pop-up window that lets you know it's launching another program. If you select a product that is within this new program, then it'll just go straight to the program. So let's do terminal unit selection. The VAV selection is the most popular of our selection programs, so we'll cover that in detail today, and then we'll go over the other products in future podcasts. We clicked on the terminal unit, and that brings us here to the home screen for terminal units. You can pick one of the terminal unit types. We're on single duct. You can click dual duct or fan powered. And then once you click the one you want, let's start with the single duct, you click Add New Box. All the information is laid out on one screen. You have the model drop down so you can pick which one you want to select. It starts with DESV, our most common digital single duct box, but you can pick a different one. You can let it auto size for you, so you just put in the airflow parameters and it'll select a size, or you can pick a size that you want it to be if you need a certain size. And then you can pick between no reheat, electric, or hot water. We'll leave that at none for now, and let's put in some CFMs. So say the design CFM is 800 CFM, and it'll auto-populate the minimum primary airflow. This is actually set in the program, but you can change it. It's defaulted to 55% of the design airflow for the minimum. There is no heat, so you can't do anything with heating. Primary inlet static pressure is defaulted to 1 inch. This is pretty common. 1 inch is a good kind of rule of thumb to start with, but if you know that you have a box that's going to be in an area that has higher static pressure, like maybe you have 1.5 inch or 2 inch, you should select it with that static pressure because it will make a difference in the sound of the box. Downstream static pressure is how much you have after the box. So this is basically your ductwork and your diffuser. 0.25 is a good rule of thumb here as well. If you have an attenuator, you can select it here. We'll leave it at no. Standard outlet, or you have attenuator or multi-outlets or round discharge. Standard outlet is the most common. And then you can pick your liner. So you can pick from any of our liners, and the liner will affect the sound, so it is very important to select the liner that you are using in your application. We will leave it at 1/2 inch fiberglass for right now. Now you can pick right hand and left hand of the box. This is more for when our reps go to order it, but it allows you to select it here, and then that information is exported into our pricing program later. This middle section is for catalog attenuation. It tells you the attenuation used to get the room sound pressures, and therefore the NC, for this box. You can get pretty specific. It defaults up here to what we have in the catalog, which is what is required of us by AHR 885 to put in our catalog, or you can be very specific and click the More down here, and it'll pop up another window for you, And here you can say what type of ceiling type you have, so you can get pretty specific here. I'd say the most important is if you have no ceiling, to select it with no ceiling. You can put in some user specified. Maybe you know the specific attenuation of the space it's going in. Down here in a discharge path, it's pretty much the same thing, you just have a lot more options. You can pick between different types of lined ductwork or unlined ductwork. Again, if you have unlined ductwork, that will make a big difference in sound, so you should select unlined ductwork if that is the case. How many elbows, T's, you can get real specific like I said. I'm going to leave it at the catalog attenuation, and so we'll just say accept. So now we've put in our parameters, 800 CFM, 440 minimum, at 1 inch inlet, 0.25 downstream, and click calculate. So you can see the different selections down here. It starts with the size 8, that's the smallest box that will meet our needs, and it goes up to a size 16. If you select the selection info button down here, you can see it says that a size 4, 5, 6, and 7, the primary airflow is out of range, so those size boxes wouldn't do the 800 CFM. It's also telling us that the size 14 and 16 box down here, the minimum CFM may be out of range. Now this is dependent on whose DDC controls you have. Different controls can go to a lower flow, but this is just kind of telling you the 440 CFM minimum primary airflow may be too low for some manufacturers' controllers to handle. So now you can see for this first box, size 8 with an 8-inch inlet, the minimum static pressure, that's the pressure the box needs to get the air from the inlet to the discharge, is 0.03 inches. The radiated NC is 25, the discharge NC is 24. If you want to see all of the sound data, you click Extended Sound Data. And now here you can see for that same box, you can see the max CFM is 900. This first section is the radiated sound power level. So the radiated sound power is here, 63, 57, 50, 45, 44, and 39 in the 7th band. And then over here is the discharge sound power. And then to the right, you see the radiated sound pressure, discharge sound pressure, and the room NC. Now the radiated and discharge room sound pressures are basically the radiated sound power and discharge sound power minus these attenuation factors up here that you had accepted, and that will give you the sound pressure of the room. And if you plot that on an NC graph, you'll see it's an NC 25 for radiated, or down here an NC 24 for discharge. So let's say we want that size 8. We'll go ahead and we'll do a save and new. And let's put in a couple more boxes. Put in 1200 CFM, it immediately populates the 660. Here, let's say we want to go to 500 CFM. Hit tab, 1 inch is good, 0.25 is good, and then we'll hit calculate. So we're going to pick the size 10 and do another one. Okay, so on this one, let's put some reheat on it. Let's do our same 1000 CFM, say. It auto-populates the minimum primary and heating. I think we'll leave that where it is. It's also changed our unit to attenuator yes, so that when you get the electric heat, you get it in an attenuator section. There are two methods to do the analysis with electric heat, kW and leaving air temperature. I like the leaving air temperature method because ASHRAE recommends no greater than 15-degree delta T in heating. So you can leave that there. You can tell it what the temperature supply air is, what you want your leaving air temperature to be, and what your max coil leaving air temperature is. It also gives you the option of doing SCR heat or staged heat. SCR heat gives more comfort, so we're going to leave it at SCR heat. And you can select your voltage and your phase. Over here on the right is your attenuation now, so I'm going to leave that where we had it on catalog and click calculate. So now it's picked several different units for us. Let's say we want to do the size 10. We'll put that in there. And now let's change this one to a hot water. (1400 CFM). We'll go ahead and leave the minimums and heating CFMs there. I'm going to take the attenuator off now. Now in the heating section, you have several different methods you can solve by now. If you click the little I over here for information, it gives you information about each of those methods. Again, I like to use leaving air temperature as my selection method, but one thing to remember is that water coils are sized for the discharge of particular VAV boxes. So if you're trying to get two manufacturers' water coil performance to match exactly, you may not be able to get all of the parameters to match exactly. The different boxes will have different size dimensions on their water coils. So you'll have to choose what's the most important and hold that and solve for the rest of the parameters. So I'm going to leave it at leaving air temperature. We'll say 55 is our supply. We actually want to go about 90-degree leaving air temperature. You can pick between 10 fins per inch or a high capacity 12 fins per inch as well. You can do right hand or left hand. Entering water temperature, max water flow, I'll leave those where they are, and now let's say calculate. So now it's selected again. We'll go ahead and pick the size 12, and now let's do a save and close. So we'll get here. This is what our schedule looks like now. So you can see the 4 boxes we've selected, their max and min CFMs, the inlet and downstream pressures, the minimum CFM for the boxes. This last one had the water coil, so this 0.42 includes the water coil pressure drop. The sound of the boxes. If we scoot it over, you can see the electrical information. So the electric coil unit has electrical, has MCA and MOP. It shows you what type of reheat is on it, whether it has attenuator, the type of lining, the kW or rows, depending on what type of heat you have. And over here you're leaving water temperature, GPM, and the MBH. Now let's do a quick selection. We'll do a fan box as well so you can see the differences. It's very similar, but you do have the fan CFMs to look at. So we'll go here, add a new box. I'm going to do the TFS series box, and let's put in 1000 CFM. It automatically populates the fan airflow because in a series fan powered terminal, the fan airflow has to at least be equal to the primary airflow. So it starts there. You can always change this, so maybe your fan is doing 1200 CFM and you're always pulling in a little bit of plenum air. That's okay, you can put it in here at 1200 and that works, but you can't go lower than your design primary airflow. Your minimum airflow is here. Again, it's set to 55%. I'm going to go ahead and leave it there. You have 1 inch primary inlet pressure, 0.25 downstream. When an ECM motor is available on a fan box, you can pick between the standard and the ECM motor, and you can pick the voltage you want as well, and the liner. Let's change this one to EcoShield. Again, you have your attenuation factors in the middle. We're going to leave those as are. We're going to leave those as they are and go to calculate. So now you can see it shows the unit size, the inlet size. So a C10 is a casing size C with a 10-inch inlet. The minimum pressure of the unit, in this case 0.13 inches. The fan static pressure is 0.25. You actually set that up here. The fan horsepower, so you can see the first 2 are 3rd horsepower, the next 3 that are shown are 1/2 horsepower. If you want to see the fan curve, you just click on this and you can see the fan curve for that, where it says fan curve, and it'll open up the fan curve for you. So now you can look at your fan curve and you can see where your operating point is, and you decide if you're too close to the top line, so maybe you don't have a lot of room to move if something changes in your system, or maybe that's okay. Let's look at one of the bigger horsepowers. So here's the 1/2 horsepower, size D10. You can see your fan operating point is way lower on the fan curve than it was before. Which box is better for you really depends on your application. Both were pretty decent size selections. You just don't want to be too far on the top of the line or on the line or too far on the bottom line. Your radiated sound, your discharge sound. In this case, the fan boxes do have electrical components, so you see the MCA and MOP here. And then clicking the extended sound data tab gets your radiated sound power, your discharge sound power, and then you also get radiated and discharge sound for fan only. So you get fan plus primary first over here, then radiated and discharge sound for fan only, and then next you get the room sound pressure levels and NC for the worst case of these first 2 data points, which is usually fan plus primary. So let's say we want the size C12. Let's save and close so we can just look at this. So a couple features that you can do over here, you can select on a line and click on Copy Line Item and tell it how many times you want it to copy and hit Accept. You can see it says it's successful. So now we have 5 of the exact same lines. So you could go in here and now edit one of them, say fan power VAV box 3. We'll double click on that to go edit it. It comes in here and say this one, turns out it's a 1200 CFM box. It updated the fan for me when I hit Tab, click Calculate. Now it's got that information. We'll save and close, and it's updated that on our schedule to 1200 CFM right here. So you can see all the data, the liners, and all that information is here. Up here at the top, you can see project totals. So you can see the total airflow for all the boxes I've added to this job. You can see the kW or amps, and you can see the MBH and GPM. Let's go back to our single duct. One other thing that I like is that you can come in here. I selected all of these at fiber-free liner, but maybe you realize that they should all be EcoShield. So I'm going to click and then shift-click the bottom to get all of them, just like you would say in Excel. And you can do global change and pick something to change. So you can change any of these things. I'm going to do liner because that's a fairly straightforward one. Pick the new liner, click Apply Changes. It's telling me it's been validated, so it actually goes in and changes all the data and updates all the data. In this case, the sound data is the same between the fiberglass and the EcoShield, so you won't see a data change, but if you went to another liner, say Sterilock, which does have a sound difference, you'll actually see it show up in the program because it'll recalculate it. Say close, and now you can see all of our liners here are EcoShield. The last thing I want to show is the reports. So you can do launch reports. We'll say I want to see a project schedule for single duct and fan powered, because that's what we've selected today, and then launch report. So this is the single duct schedule. You can see VAV 1, 2, and 3, the unit size, the outlet size, the CFMs, the pressures, the sound level, and the electric heat on this one. And then on page 2 is where it put my water coil. So you can see the one unit with the water coil has the water coil data. And then on page 3 is our fan boxes that we added as well. So you can see all of the performance data in the schedule. Once you get this print preview, you can click this little export button, export to Excel, PDF, or Word, and then from there you can use it anywhere. You can copy it and paste it into, say, AutoCAD drawings or anything. So let's close that, and now let's go to reports again and look at the performance reports. So we'll do both of these. So here is the single duct performance, and it's going to do this one for every box. So this is VAV 01. You can see the performance for VAV box 01, and it gives you the sound data, everything that's on it. VAV 2, VAV 3, you can see this one had an electric coil, so it's got the electric coil information down here. And then this one had the hot water coil, so it has the hot water performance data on it. And then on the fan boxes, you can see it's got the same information with CFM, pressures, sound level, but it also includes a fan curve and your operating point on it. So now you can have these for every box on the project. And again, you can export using just the export button right here. Okay, so let's close that. So that's how you do VAV selections in Teams. Don't forget to subscribe to our YouTube channel, and thanks for taking a time out with us.